So we've all gotten pretty used to AI that can chat with us or whip up an image. But there's a new class of AI here, one that doesn't just respond, it acts. These are AI agents, and their ability to work on their own is opening up a brand new frontier of cyber risk that we really need to get our heads around, like right now. So let's dive in and break down what this really means for security.
Okay, so what exactly is an AI agent? Well, the key phrase here is act autonomously to achieve goals. You see, unlike a regular chatbot, you can give an agent a big, complex objective, and it will actually reason, create a multi-step plan, use different tools to execute that plan, and even change its strategy based on the results it's getting.
Here's a really easy way to think about the difference. Generative AI is kind of like a great assistant you give single, specific tasks to. But agentic AI, that's more like a family manager. You don't tell it how to plan a vacation, you just say, plan a beach vacation for next month. And it just figures it all out, the flights, the hotel, the activities, everything. And this highlights a huge shift in responsibility. When the agent is handling all the details, what we need to worry about changes completely.
And that autonomy, that ability to act, fundamentally changes the entire security game. For years, our main focus in cybersecurity has been on confidentiality, keeping our secrets safe from being stolen. But when you have an AI that can book flights or run code or send emails on your behalf, the focus shifts, and it shifts dramatically to integrity. The big question is no longer just, is our data safe? It's, can we trust the agent's actions? Can we be absolutely sure it's doing what it's supposed to be doing and not what an attacker tricked it into doing?
So this brings us right to the core of the challenge. How do you attack an agent's integrity? Because these systems are built to follow instructions and use data, attackers have found some really clever new ways to hijack that exact process. Probably the most common threat you'll hear about is called prompt injection. At its core, this is a trick where an attacker hides malicious commands inside of data that the agent is supposed to process, like in an email, a document, or just some text on a web page. The agent reads this data as part of its job and gets tricked into running the hidden malicious instruction.
The babysitter analogy is honestly the perfect way to understand how this works. Imagine our agent is a babysitter, and it has one main instruction: look after the kids. Pretty simple, right? But then a pizza delivery note shows up. This is untrusted data from the outside world. And hidden in that note is a brand new command: order a bounce house. The agent, which is designed to process all the information it receives, gets its priorities completely mixed up and ends up executing the malicious command, totally failing its original mission. Now, another really insidious attack is something called data poisoning. A lot of these agents use a technique called retrieval augmented generation, or RAG. That's just a fancy way of saying the AI doesn't just rely on its training data, it can look up current info from outside sources, like your company's internal wiki or the public internet, to give you better answers. While data poisoning is when an attacker manages to corrupt those trusted sources of information.
This quote just nails the danger perfectly. The AI agent is the expert chef, and its knowledge base is that trusted recipe book. If an attacker poisons that book by adding a dangerous ingredient, the chef will follow the recipe perfectly and serve up a toxic meal with absolute, total confidence, because it has no idea its trusted source has been compromised.
And finally, we have these stealth threats. On one side, you've got shadow AI, which is when your employees are using unapproved AI tools with sensitive company data, creating all sorts of risks your security team can't even see. On the other side, and way more malicious, you have sleeper agents. These are adversarial models that are designed to just lay dormant inside a system until a specific trigger, like a date or a keyword, causes them to wake up and execute some kind of damaging payload.
Okay, so the threats are real and they're new. So how in the world do we defend against them? Well, the answer isn't a single magic product, but a new piece of security architecture that we call the AI Gateway. This is honestly the best way to think about an AI gateway. It's a mandatory checkpoint for any and all AI-related traffic. Every single request going to an AI agent and every single response coming back from it has to pass through this one single controllable point for a full inspection. So this gateway has two really critical jobs. First, on the way in, it scans all the incoming prompts looking for signs of prompt injection. It uses specialized AI models called metaclassifiers to spot the patterns of a malicious instruction. Second, on the way out, it filters all the responses to stop data leakage. It's scanning for things like PII, personally identifiable information, or internal company secrets before they can get out.
Now, beyond the gateway, we have to limit how much damage an agent could possibly do. We call this the blast radius. This means enforcing the principle of least privilege to things like role-based access control or RBAC. In simple terms, this just means the agent only gets permission to use the specific tools it absolutely needs for its current task and nothing more. We could also use techniques like context separation to help the model tell the difference between its core instructions and untrusted data. And maybe most importantly, we can isolate each user session in its own secure, sandboxed environment, like a micro VM.
But look, a strong architecture by itself is not enough. Securing these agents requires a dynamic, ongoing strategy of vigilance. We can't just set it up and forget about it.
This is where observability comes in, and this game film analogy is just perfect. When an agent messes up, you can't just look at the final error message. You have to be able to rewind the tape and watch its entire decision-making process, step by step, to figure out the real root cause of the failure.
And this means we need a whole new level of observability. We're talking about capturing the agent's entire reasoning path, every single tool it uses, the full context of the session, and even its own confidence scores for the decisions it makes. Your traditional application logs, they just aren't going to cut it anymore.
To find the weaknesses in your system before the attackers do, you have to adopt an adversarial mindset. And that is the entire purpose of red teaming. You form a dedicated team whose whole job is to think like an attacker and put your AI systems through some really tough, realistic challenges.
Einstein's words here are just so relevant. The thinking that goes into building these powerful AI systems is optimistic. It's focused on all the amazing capabilities. The thinking you need to secure them has to be critical, it has to be skeptical, and it has to be adversarial. You need a completely different perspective.
And this is where the whole process gets really concrete. A red team's job is to proactively simulate all these attacks we've been talking about. They should be trying to inject prompts, poison data, and find those sleeper agents. And just as importantly, they have to map their findings to established frameworks, like the NIST AI risk management framework, so they can clearly communicate the risk to the rest of the organization in a language everyone understands.
So let's wrap this all up. First, the arrival of autonomous agents shifts our main security worry from protecting secrets to guaranteeing integrity. Second, the foundation of your defense has to be a layered gateway architecture that inspects all AI traffic. And finally, security is not a one-time setup. It requires continuous assurance through deep observability and proactive red teaming.
That brings us to the end, and I'll leave you with this final thought. For years, we have built our defenses against static code and predictable scripts. But now, for the first time ever, we're facing an adversary that can reason, plan, and adapt on the fly. So the real question you need to be asking is your defense ready for that?